Welcome back to Miss Powers Teaches Algebra. We are going over arithmetic sequences, you guys. They're amazing. They're actually really easy. And, okay, when you see arithmetic sequence, if you're going to relate these things to functions, as we said we can, because a sequence is a function pretty much, right? Lots of these are functions. No, they're all functions. But the domain is, the whole numbers, kind of like 1, 2, 3, 4, 5. That's our domain. We don't like have a x can be 1.5 or 1.3 or anything like that. So if they're going to relate this to a function, these arithmetic sequences are linear functions. Okay, you can think of that linear functions. And at the end or somewhere in the middle of this video, I'll show you in particular these guys. But when you're thinking arithmetic sequence, well, let's look at this first and then see if we can find that relationship, okay? Because what's a linear function? It's usually something in the form of y equals mx plus b, right? Okay, so if we're going to rewrite this as a sequence, it would maybe be something more like a sub n equals, I'll use n instead of x. Okay, so it would be n instead of x. And m, we're going to say d. So x turns into n, y turns into a sub n. And then plus b, I could say, you know what, maybe that's like my first term. So it might be something like that. We'll see. We're going to fiddle around with this. N times d plus our starting term, right? Plus something. So let's look at the definition of arithmetic sequence, see if it's similar to this. And if it is, then yeah, these are very, very similar things. And we can use that to get explicit formulas for these and very, very easily figure those out. So here we go. An arithmetic sequence is a sequence that has a property that the difference between any two consecutive terms is a constant, any and all. This constant is called a common difference, and we're going to call that common difference D. Hello, common difference D. Ooh, that is kind of like M. Think about it. That's like our slope, right? You'll see. If a sub 1 is the first term of an arithmetic sequence and D is the common difference, then the sequence will be, okay, and this makes sense. It'll be, we got a sub 1, then add that common difference. So a sub 1 plus D. Then add D again, right? We're just going to keep adding that common difference over and over again. Add the common difference again. And we're going to get, excuse me. Okay, we're going to get, we'll add common difference again. We get a sub 1 plus 2D. Because now we have 2Ds. Add it one more time. I'm sorry here. I'm hearing noises. Okay, a sub 1 plus 3D is what we'll get because we added D one more time. So 2D turns into 3D. All right. And so what is this looking like, right? Because this is when n equals 1. Here is when n equals 2, right? This is my a1. Here's my a sub 2. Here's my a sub 3. This is when n equals 3. Here's a sub 4. So this would be n equals 4. Actually, I can already see a pattern. I did this with my class this morning, and now I'm seeing another way to get the formula. I kind of like the way I'm seeing already. You could maybe see our pattern already, but this is definitely this form. So like we're getting our slope. What's slope? Slope is the change in y over change in x, right? Or you could think of it as we change in our x's by 1, the slope gives us that change in y. So it's how much we add between each term. Well, that would be our common difference. So the m and the d, in this case, are exactly the same thing. If we were to plot this out, our d is our slope. Our common difference is our slope. And we're going to see that when we take a look at this in a graphing calculator. So it is something like this, but it's not going to be this. This isn't going to work. That's not going to work. You'll see. We're going to get something else, but it's going to be similar to that. Okay. Let's look at these. We got a few examples here to look at, and then we'll get our formula. Okay. So common difference. 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. So we are adding 3 each time. Our common difference is 3. Right here, we're going 80 to 75 to 70. Is this arithmetic? Of course it is. I'm giving you guys examples. So what is 75 minus 80? That's negative 5. Our common difference is negative 5. 75 to 70. What's that? 70 minus 75 is negative 5. And so our difference is here, the way I got it, was 70 minus 75. And I'm saying it, I'm showing it to you, because this is important. This is how you find the common difference in a very easy way. Is you take any two terms, subtract the term that came later, subtract from that the term that came before it. And that'll get us our common difference. So here, 65 minus 70, negative 5 again. I'm adding negative 5 each time. 60 minus 65 is negative 5. So we can see we got that common difference. Pi over 2, pi, 3 pi over 2, 2 pi. What's pi minus pi over 2? Pi minus half a pi is half a pi. So in this one, we're adding pi over 2 every time. Add pi over 2, add pi over 2, add pi over 2. 3 halves pi, 2 pi, 5 halves pi, and so on. We're going to get that. Okay. And then here's another one. What are we adding to each time in this one? We are adding, let's see here, negative root 2 and negative 2 root 2. So what is right here, right? Their difference is going to be negative 2 root 2 minus negative root 2. So negative 2 root 2, and that's actually plus root 2. So that's going to give me negative 1 root 2. So we're subtracting root 2 every time. So from here to here, negative 3 root 2 minus negative 2 root 2 is negative root 2. And so forth. And then here, negative 3 root 2 to negative 4 root 2. Again, we're adding negative root 2. Okay, so there's enough examples. Now let's go ahead and find a formula, an explicit formula. What do we do if we're given a sequence and we want to find, maybe I got this sequence right here, and I want to find the 80th term. Am I going to, let's see here, add 3 every time? Am I going to want to do that 80 times? Put it in a spreadsheet maybe, add 3, go down 80 times? No, I don't want to do that. I would rather have an explicit formula and just plug in 80, right? So if I wanted a sub 80 here, the 80th term, it would be much easier to have this. A sub n equals, to figure out a nice explicit formula for it. Okay? So what is that explicit formula? What are we going to do? Well, let's go back up to this actually. Actually, I'd rather look at this. So let's go ahead and take this, and then we'll see if it's going to work for us. Let's see if we can take this rather and make up a formula for us. And we, of course, what do we need to know in this? We need to know what our a sub 1 is and our common difference. So if we know what those are, then we're going to be able to find a sub n. So what's the pattern? For this one, this first term, a sub 1 here, we could rewrite it as a sub 1 plus 0 times d. That's my a sub 1. Okay, my a sub 2 was right here. That's a sub 1 plus 1 times d. And then we have a sub 3 right here was a sub 1 plus 2d. And then this one right here, a sub 1 plus 3d, that was my a sub 4. So what we want to do is see, is there a pattern emerging here between my n's and these expressions right here? So these expressions right here and the n's, the number that each one of these is, the term. So if it's a sub 1, remember that means n equals 1. If it's a sub 2, our n equals 2. If it's a sub 3, my n equals 3. Right? Here n equals 4. What's the relationship? Well, the a sub 1 is always the same. The only thing changing is this part, the second part, 0d, 1d, 2d, 3d. How do you go from 1 to 0? How do you go from 2 to 1? How do you go from 3 to 2? How do you go from 4 to 3? That's easy. It's just one less, right? That's just one less. So this guy could really be written as a sub 1 plus 1 minus 1 times d. This guy could be written as a sub 1 plus 2 minus 1 times d. 2 minus 1 will get me the 1. And now I got my n in there. This guy could be a sub 1 plus 3 minus 1 times d. And this guy could be a sub 1 plus 4 minus 1 times d. All right. So n equals 1, there's a 1. N equals 2, there's a 2. N equals 3, there's a 3. N equals 4, there's a 4. There, I got my pattern. I got my pattern. All that is going to imply that a sub n is really equal to a sub 1 plus n minus 1 times my common difference. And there it is. If we're given a first term and a common difference, we can easily get our what's it called? We can easily get our explicit formula. Now this video is already running on 15 minutes. So in the next one, what we're going to do is we're going to use this formula to find a explicit formula, and then compare that with, like, say, a line and everything, and make those connections again. So here again, really quick, to just see that, written out nicely, but there it is. So thank you for watching, and until next time, enjoy doing math.